Hello, dear students. I am Mohammad Tajamul, and I am here to deliver a presentation on the subject computer programming and problem solving. Okay, so in this we are having the first unit, that is the introduction to algorithm. Okay, so the main topic or the subtopic for the today presentation is classification of algorithm. Okay, classification of algorithm or the types of algorithm, or classifying the algorithm means to know various types of the algorithm. To know various types of the algorithm means how many types of algorithms are there. But the main reason behind this classification of the algorithm is that we must know different types of algorithms, so that we can use them in different situations. Okay, because there is no just one algorithm, there is no just one algorithm which is fit in all the situation, which is fit in all the situation, or which is appropriate for all the situation or for all the problems. There is no one size fit for all the formula. Okay, there does not exist one size fit for all formula. Okay, so this is true in the case of algorithm. If we are having different types of problems, so different types of algorithm exist for that. Okay, if problem is there and algorithm does not exist, so what we should do, we should prepare an algorithm that must produce the best solution for that problem. Okay, so if we are having different types of situations, so first of all what we should do, we should analyze the different algorithms. Okay, suppose we are having already a number of algorithms and we have already analyzed those algorithms. Okay, so what is happening with us, we are analyzing those algorithms. So after analyzing those algorithms, what we will do, we will know lots of knowledge, or we will have lots of knowledge about those. Okay, if we are having lots of knowledge about those, okay, so it will be very easy for us to use the best algorithm or to choose the best algorithm out of bulk. Okay, if we are having a problem, or we are having a bulk of algorithms to satisfy or to solve that problem, so what we should do, we must choose the best out of bulk. Okay, because there are large number of algorithms that can solve that problem. Okay, for example, if there are two algorithms, okay, and one problem is there, and there are two algorithms, or two algorithms exist for solving that problem, so which of these two algorithms we must choose? Okay, so we should go for their time complexity as well as space complexity. First of all, we will compare, we should compare their time complexity. If their time complexity is same, means both of the algorithms are taking only 2 milliseconds or 5 milliseconds, means both of the algorithms taking same time, okay, to sorting out the problem. So then we must go for the space complexity, and we must choose that algorithm which is taking less amount of memory, less amount of space. Okay, but this situation may be different. How this situation may be different? For example, there is a user, okay, having enough time, okay, but having very small amount of space. Okay, for example, there is a device, or there is a mobile device. Okay, okay, its processor is very small processor, but its memory is very heavy. So we must choose that algorithm, okay, that is taking very small time of processor. Okay, means time complexity is very low. Okay, but the space complexity is little bit higher. Okay, but if there is a system in which space is very low as well as processor is very high, okay, a very high speed processor, so in such situation we can choose an algorithm that is taking uh, uh, less space and more time, no problem. Okay, because the processor is very fast, so it will produce the result, or it will run the algorithm very fast way. Okay, it doesn't matter whether the algorithm is slow. Okay, next, so these are the prerequisites, means before moving further, okay, we must know, or somebody, or any student want to know some properties of the algorithm. Okay, he or she must know these subjects, or he or she must have some knowledge of these subjects, or knowledge of this subject means computer fundamentals. Okay, he or she must have some knowledge about the basics of computer. Okay, means basic knowledge about the computer. Okay, or the that is also called fundamentals of the computer. Okay, knowledge of programming syntaxes means what are the syntax of a programming language. So what is the syntax? Syntax means format of a programming language. Okay, means rules of the programming language more formally. Next, the knowledge of the programming semantics means what is semantics? Semantics means the meaning of a program. Okay, suppose we are having a program or we are having an algorithm. Okay, so semantic means it will tell, semantic will tells us, okay, semantic will tell us the meaning of each and every statement or each and every word used in the programming or used in the algorithm. So means we must know the semantics as well as syntax also. Okay, so programming applications or computer programming applications. In this computer programming applications, what we are going to discuss today, we are going to discuss the types of algorithm or the classifications of algorithm. So an algorithm is a set of self-contained sequence of instructions, or an algorithm is a collection of steps that is producing output after following some steps. Okay, or once we are here or we are in starting step and we are reaching to the final step, so we are reaching from problem domain to the solution domain, or from problem to the solution. Okay, so an algorithm is a set of self-contained sequence of instructions or actions that contains the finite space or sequence that will give us a result to specific problem in finite amount of time. Means this algorithm or this step or these three lines or this definition is satisfying or saying all the properties of the algorithms. Okay, it is saying us finite amount of time. So what it is saying means it is saying us that algorithm should be finite, or the number of steps or the time taken or the space taken by the algorithm should be finite. Next, it is saying sequence of instructions. There should be some sequence of instructions or well-defined collection of statements. Okay, so it is also saying or satisfying all the properties, and sometimes it is saying us results. Results means output. Okay, so next is it is logical and mathematical approach to solve or crack a problem using any possible method. Okay, if there are large number of methods, okay, there are large number of methods. Okay, so we are selecting some methods out of those. Okay, or we can say this those methods are logical methods or mathematical methods. Okay, behind the behind those methods there is some mathematics or some logic. Okay, that is means if we are having an statement or some statements inside an algorithm or some steps inside algorithm. So if you are writing an step at step number 3, suppose, so there should be some logic behind that why we are writing step number 3. Okay, and there should be some mathematics. What is the output or what are the benefits of writing this step? Means step number 3. Why we are writing that step? Okay, we must have some reasons. Okay, next. So these are the types of algorithm. Well, there are many types of algorithm, but most fundamental types of algorithms are as number one, recursive algorithm. Recursive algorithm means what is recursive? Recursive means if there is a parent problem, there is a parent problem, so the same concept can be applied on the child. There is parent problem, it must be broken into number of childs. Okay, if parent is having some properties, so child must also have same properties. Okay, so that we can sort out the childs, or we can sort out the problem related to posed on those childs. Okay, and then after solving all the childs, okay, we must collect the solution. This solution will produce the solution for their parents. Total solution will produce the solution for their parents. So it was all about the recursive algorithm, or we can say in simple way that recursion is a process in which a function is called itself in its body again and again. So for recursion we are having a very good example, that is Fibonacci as well as the factorial of a number. Next is dynamic programming problem. Actually we use dynamic programming problem for optimizing the solution. Suppose we are having a number of solutions. Okay, so we want to find out the optimal solution for the given problem. So in such situations we must use the dynamic programming algorithms, or dynamic algorithm. Next is backtracking. So what is backtracking? Backtracking is used for the brute force algorithms. Okay, suppose we are having brute force. Okay, brute force means we don't have, suppose we don't have any idea about solving the algorithm, and we start or we take some initiative to solve that problem. Okay, so we are having lots of solutions, and suppose we reach to the nth position, and from this position is it possible for us to go to the back? If it is possible for us to go back, then the problem is called backtracking type problem. Okay, for example we are having two boys and one girl. Okay, so there will be some uh, situations, or to set out these three students, or to place these three students in three boxes, or in on three chairs. Okay, so for such situations, though this situation will be sorted out by using the state space trees, by using state space tree. Okay, next is divide and conquer algorithm. Divide and conquer means, suppose there is heavy problem and we are going to divide this problem into a number of sub problems, and we are finding out the solutions for these sub problems, and these sub problems may or may not be dependent on each other. Okay, now what is happening? Suppose problem is there, and we are going to divide this problem into number of sub problems. Suppose problem is p, and we are going to divide this problem p into p1 p2 up to p10, and then we are sorting out. What we are going to do? We are sorting p1 and then p2 up to p10. So total solution will be the solution of the main problem, that is the p. Next is greedy algorithm. Greedy means uh, that is called lalche in Hindi. इसको बोलते हैं लालचे. So suppose we are greedy algorithm means uh, choosing the best out of bulk. Suppose there is a thief, it is or is going into the uh, jewelry shop. Okay, so what it will take? It will take, first of all it will take the platinum from there, and then gold. Okay, and then silver. It will not started taking the silver and then gold and then platinum. No, first of all it will take the best, that is the platinum, and then gold, and then the silver, and so on. Next is brute force algorithm. Brute force algorithm, suppose we don't have any knowledge or any domain specific knowledge. So in such situations we start through the brute force nature. Next is randomized algorithm. Randomized algorithm, in the case of randomized algorithm, we choose a random number, or randomly what we are doing in the case of quick sort. Okay, we are randomizing, or we are using a random number. Okay, or randomly we are choosing a pivot. Okay, or we are dependent on random. Next is simple recursive algorithm. So let me discuss each and every algorithm in little bit broad way. So what is a recursion? I already discussed. A recursion is a process in which a function is called itself in its body again and again. Okay, or recursive problems are those problems. Suppose parent is there and it is having some properties. Okay, and we are dividing that parents into number of childs. Okay, or we are breaking the parent problem into number of or a large number of children problem. So the same the properties of the parent should be there, exact properties should be there in the children. So this type of problems are called recursive problem. Solves the so recursive problem solve the base case directly and then recurs with a simpler or the easier input every time. Next, it is used to solve the problem which can be broken into smaller or smaller problems of same type. Means parent's problem, parent is there, so the same thing will be there in the, or the same properties will be there in the children or child. So we are having an example, that is the Fibonacci series. Suppose fact x or factorial x, finding out the factorial by using the recursion. If x is 0, if x is 0, then it will return 1 because the factorial of 0 is always 1. Okay, else it will return x into factorial of x minus 1. If fact is x, fact x is there, suppose x is 5, so fact of 5, so what we are doing here, 5 into fact of 5 minus 1 is fact of 4. If we are having fact of 5, so similar way we are finding out the fact of 4, means fact of 5 means fact of integer, and then fact of 4, it is also fact of integer. So means it is a problem of uh, it is a problem of recursive type problem. Next, we are having dynamic programming algorithm. As I already said, dynamic programmings or the dynamic programming problems or the dynamic programming algorithms are used in the situation where we want to optimize the solution. Okay, or these algorithms are called optimized algorithms. Okay, or optimization type algorithm. A dynamic programming algorithm, also known as dynamic optimization algorithm, remembers the past results. Okay, if you are producing some results, so it is remembering the past results. How it is remembering? It is remembering in the same way as the flip flop remembers the previous results. Okay, or the sequential circuit remembers the previous results. Okay, and on the basis of that it produce the next results, or in next iteration it will try, or it tries to produce the good result than the previous one. Okay, so remembers the past results and uses them to find the new results. Means it solve the complex problems by breaking it, or breaking it down into collection of simpler subproblems, then solving each of these subproblems only once and storing their solution to for future use instead of reconstructing their solution again. Now, what is the meaning of this completely? So dynamic programming problem or dynamic algorithm are used for finding out the optimizations or optimal solution for the given problem. Now what is happening, if in the case of recursive problem, we were dividing parent problem into sub problems, so there was a possibility that there may or may not be the relation between sub problems, but in the case of dynamic problem there will be some relations between the sub problems. Okay, so this is the difference between dynamic problems, dynamic algorithms, and recursive algorithms. Next example for the uh, dynamic programming problems or the dynamic algorithm is Fibonacci sequence or the Fibonacci series. So here is the pseudocode or the simple programming statements. That is, fib n means Fibonacci of n. If n equal to 0, then it will return 0. Else, what it will return? It will return previous of Fibonacci equal to 0 and current of Fibonacci equal to 1. Okay, so let me explain this in more specific way or more deeply. So repeat n minus 1 times. If n equal to 0, it will skip. Okay, if n equal to 0, so it will be skipped. Otherwise, it will be repeated n minus 1 times. Now, next of Fibonacci equal to previous of Fibonacci plus current of Fibonacci. Suppose I want to find out the nth term of the Fibonacci series. So it will be the sum of n minus 1 plus n minus 2 steps, or suppose I want to find out the nth term of the Fibonacci series, Fibonacci n. So what will be there? So I will try to find how I will find out the solution for that Fibonacci n. I will find out Fibonacci n minus 1 plus Fibonacci n minus 2. Means if I want to find out the nth term, so what I should do? I should add first two terms or the two previous terms to the n terms. Okay, how I will find out? I will find out the sum of n minus 1 term plus sum of n minus 2 term. Okay, n minus 1 term plus n minus 2 terms. So it will produce n term. Okay, so now there will be some updation. The previous of Fibonacci equal to current Fibonacci, because in next iteration we will use a previous of Fibonacci as this current Fibonacci. Okay, next current Fibonacci equal to new Fibonacci. That new Fibonacci means the next Fibonacci that we have produced. So that is the new Fibonacci. The current Fibonacci will be the new Fibonacci and then return current Fibonacci. So it will produce or it will produce the next term in the Fibonacci series or the sequence. Next is backtracking algorithm. As I already told you that backtracking algorithms are used where are used in the situation where we are using the brute force algorithms. Brute force means if you don't know the solution, we don't know how to proceed to the solution from the problem, and we will start taking any initiative. Okay, and we are finding out some solution, and then again we are finding out the next solution, but we will keeping in mind the previous solution also, so that we can jump any one of those. We can jump any one of those. Okay, there are suppose a number of solutions. Okay, and it is possible for us, suppose we are making any space state space tree. Okay, and in one branch from root to the leaf node we are reaching from root to the leaf, and if it is possible for us from reaching from leaf to the root back, like in back side. Okay, or backtracking. So if it is possible for us in those algorithms, so those algorithms are called backtracking type algorithm. Okay, next is divide and conquer algorithm. Divide and conquer means we are having heavy problem. What we are doing, we are dividing that problem into into number of sub problems. Okay, and we are conquering. This is divide means problem is there and we are dividing there will be two steps or two phases. First one division and next one is conquer. In the case of division, we are having heavy problem and we are going to divide that heavy problem into a number of sub problems, p1 p2 p3 up to pn. Okay, and next is conquer, and we will keep on dividing this problem into up to that point, that we will be able to sort out a simple or the smaller problem. Okay, so we will keep on dividing that problem into sub problems. Suppose p problem is there and we are dividing this p1 into up to pn, or p1 to p2 p2 up to p1 p2 p3 up to p10. Now what we are watching here or what we are doing here, we have seen that p1 cannot be solved also. Now again we will divide this p1 into p11 and p12. Okay, again what will happen if we are dividing this p11 and p1 into p11 and p12, and we have seen this p11 can be sorted out and p12 can be sorted out. So what will happen, we will sort it out these two p11 and p12, so it will constitute the problem solution for the p1, and similar same for the rest of the sub problems. Okay, so if all these problems are sorted out, okay, then the total solution will be the solution of the given problem, that is the main problem. Next is quick sort, next is merge sort. What is these are the two examples of the quick sort, example of the divide and conquer algorithm, that is the quick sort as well as merge sort. Next is greedy algorithm. Greedy is something lalchi. Greedy means, as I already discussed, that greedy algorithm, in the case of greedy algorithm, if somebody is going there in the shop of jewelry, so for what he or she will do, first of all the thief will take the best thing, that is the platinum. If platinum is there, then he or she will go for the gold. Okay, and after taking gold, okay, so it will go for the silver. Okay, so this is called the greedy algorithm. This type of algorithms are called greedy algorithms. These are the example of Mentry is an example for the greedy algorithm. Okay. Brute force algorithm. A brute force algorithm is simply tries all the possibilities until satisfactory solution is achieved. Means in the case of brute force algorithm, the programmer or the user don't have the domain specific knowledge. He will initiate the solution, or he will try to find out the solution in best possible manner. Okay, if it is the satisfactory solution, then no problem. If it is no satisfactory solution, we go for next solution. Examples: exact string matching. Okay, KMP algorithm can be used for string matching, that is Knuth Morris Pratt. Okay, algorithm is used for string matching. Suppose there is a string, okay, and there is next string. So whether this string is matching with the previous one or not, or suppose there is a string and there is a substring, so up to what extent this substring is matching with the given string, main string. Then randomized algorithms uses a random number at least once during the computation to make a decision. For example, in the case of quicksort, as we use random number to choose the pivot point or to choose the pivot element. So these are some references. Okay. Uh, uh, in the case of books, you can go for ANSI. ANSI stands for American National Standard Institutes. Okay, American National Standard Institutes, C programming. Next, let us see, that is written by Yaswant Karnitkar. Okay, and let us see is for basic knowledge. Okay, if you are having little bit basic knowledge, so you must go for ANSI. And next is C programming by Dennis Ritchie. Okay, this is this programming or this C programming has been written by the or the book this book has been written by Dennis Ritchie, the father of the C programming. Obviously this is the best book of the programming language or C programming language, because this is written by the developer of the C programming. But this is first of all, you must study letter C. If you are studying letter C, it will be very easy for you to understand ANSI C as well as C programming by Dennis Ritchie. It will be very easy for you. Next is internet. So for the internet, you can go for Geeks for Geeks. This is the website for searching the computer science contents. Next is w3schools.com. Next is Google, and then YouTube. So thanks for listening me and bearing with me. Okay. If you are having any question, so feel free to ask me questions anytime. Okay. And thanks for listening me. Okay. Thank you. All the best.